Inequalities. The most simple and basic form of an inequality looks like this, and they're pretty easy to graph. Y is greater than or equal to 4, right? And you did this, close circle at 4 going to the right. Everybody's good with that? Then we talked about compound inequalities, which look like this, negative 6x. 4, always the less than sign. When you graph that, it looked like this. Since it's equal to here, this is colored in, negative 6. Open there, 4 colored inside, right? We did that, please say yes.
Yes.
Okay, and then we've also done OR ones, where x is greater than, no, sorry. X is less than or equal to negative 2, or x is greater than, I don't know, 7. What's the difference between an and an or? Or goes in the other direction. Or, ladies and gentlemen, is putting the two graphs together, and is the part where they overlap. I should show you that. Let's do that. You know, if I was graphing x is greater than or equal to negative 6, it would look like this. Here's negative 6, greater than or equal to goes forever this way, correct? If I was graphing this part of it, where x is less than 4, here at less than 4, the graph goes this way. I should put my negative 6 there. When you say the word and, it means both of them have to be true. And the only place where both of those graphs are true is right in between these two numbers. Those are the only numbers that work. That's why we put 4 as negative 6. Because both of them, when you say something and, if I say, you know, Ryan and Eli come over here, they both have to come. Over here, or just means either one of them can be true. Ryan or Eli come here, either one of them come. So when you do this, you know, it's the combination of both of them put together. It's not their overlap. So where x is equal to negative 2, you know, you put that there, and you put that there, and it goes this way. You put 7 here, it's greater than, so it goes that way, and that's the or. Either one of them can be true. This one and both of them have to be true. Now, unfortunately, that has nothing to do with what we're doing today. This has what we're doing today. And I think we may have brushed on these two. Okay? This one is an and problem. Wow, look at that. This one is an or problem. How do I know? It says or. This one doesn't say and, but you'd assume it if it doesn't say or. But the problem with this one is it needs to be solved before you can graph it. You'll notice there's more than just an x in the middle. Yes? You with me on that? And I think we might have done this too, did we? I don't know. Here's the deal with this. What you need to do is take a little time and actually split this. You can kind of do it together, or you could kind of split it up. Whatever way kind of works for you. I'm going to rewrite it here and show you. Negative 69 is less than 8r minus 5. Okay, minus 61. You have to think about this as an equation. You need to solve the middle for r. You need r to be by itself. So just like with equations, you got to get rid of this negative 5 first, so you have to add 5. But what you have to remember is you have to add 5 to both ends. Whatever you do in the middle, you have to do to both sides. So you're going to add 5 here, it gets rid of that. Add 5 here, and add 5 there. Because it's like you're working with two equations at once. Okay, when you add 5 here, you get negative 64. Add 5 there, you get negative, what, 56, I believe. And then you've got the 8r still left in the middle. And now to get r by itself, you're going to have to divide by 8, but you've got to divide everything by 8. And you end up with a negative 8 is less than r is less than 7. And then once you get it down to this, negative 7, sorry, right? Once you get it down to this, then you can graph it. Hopefully it fits on the graph. If not, you probably did something wrong. So it goes from 8 to negative 7. Who in our right mind did that? And then whatever's in the middle is colored in. Just that little tiny speck there. And then for number 3, it's probably obvious to you that you're just going to have to solve this side figure out what this is, and then solve this side and figure out what that is. 9k plus 2 is greater than 11. Subtract 2, you get 9. Divide by 9, you end up with k is greater than 1. Yes, why not? Hope so. Going this way. And then the other side, 5k minus 10 is less than negative 60. Add 10, add 10. 5k less than, what, 50 divided by 5 is a negative 10. K is less than negative 10. How is that? Fast and furious? So that would be that side. Is there anything worse than that? I don't know. I have this here. Oh, heavens to Murgatroyd. This one actually is on in the homework. Is this a compound inequality? Yes and or no? People? Do you see two sets of inequalities? No. This is a single inequality, but it still needs to be solved. And right off the bat, can anybody tell me what the problem with this is? If it's a single inequality, Grace?
There's parentheses.
There are parentheses, that's one problem, but that's not the biggest one in my book. When you solve single inequalities,
It's only going one way.
nah, it's still not a problem for me. When you solve single inequalities, the letter has to end up on the left side. Okay, I need to know what that, I need to move that thing over there. So in the end, we're gonna have to do that. But you can do it just like an equation for right now. Let's do 8, 9 plus n. So you do distributive property, you get what, 72 plus 8n? Okay, with the parentheses. And solving it, I would subtract 72, I end up with 16. Okay, I divide by 8, I'm still good. But here is, you cannot just look at it and do this because you'll probably get confused. You can't leave it as 2 is less than or equal to n. You want to flip these over and put the n over here and the 2 over there, but when you do that, that sign flips as well. N has to be greater than or equal to 2. Just remember, if the alligator's eating the bigger one here, it doesn't change just because the thing's on the other side. The alligator still likes to eat the bigger one there. And then here's your 2, and it's equal to. Everybody happy? Yes. It is Friday, and a 3-day weekend nonetheless.